Welcome to solverfy.
We want to know whether a precipitate will form if we dissolve 3.5 milligrams of NaCl in 0.250 liters of 0.12 molar PbNO3 2. The precipitate that would form is PbCl2. And if we write out the equation for a saturated solution of this, it would partially dissociate to Pb2 plus and 2Cl minus. We want the Ksp for PbCl2, which we can look up in the textbook, is 1.7 times 10 to the negative fifth. And our QSP expression is the concentration of Pb2 plus times the concentration of Cl minus raised to the second power because of this coefficient of 2 before the Cl minus. We want to remember that if the QSP equals the KSP, then we have a saturated solution without a precipitate. If the QSP is greater than the KSP, we have a saturated solution with a precipitate. And if the QSP is less than the KSP, we have an unsaturated solution, which means we have no precipitate. This is because a greater QSP means that we have more of these ions from this QSP expression. So the equilibrium will shift to the left by Le Chatelier's principle. If we have a QSP that's less than the KSP, then we have less of these ions, meaning the reaction will shift to the right, and so we won't have any of this solid precipitate. If the QSP is equal to the KSP, then our system is in equilibrium, so it'll be a saturated solution, but no solid precipitate will form. So now let's do the calculations so that we know which of these is true. Starting with our concentration of Pb2 plus. We can get that from our given concentration of PbNO3 2. So we have 0.12 molar PbNO3 2, and there's a 1-to-1 ratio between PbNO3 2 and Pb2 plus. So this implies the same concentration of Pb2 plus. If you want to see this more explicitly, we have 0.12 moles of PbNO3 2 over 1 liter, because moles over liter is molarity. And then we can multiply by the mole ratio, so 1 mole of Pb2 plus to 1 mole of PbNO3 2. These units here cancel out, and 0.12 times 1 divided by 1 is just equal to 0.12, and our units are then moles of Pb2 plus over liters of solution, which is also just 0.12 molar Pb2 plus. To get our concentration for Cl minus, we know we have 3.5 milligrams of NaCl, and we have 0.250 liters of solution. We can then convert our milligrams of NaCl to grams, where 1 gram is equal to 1,000 milligrams. Then now that we have grams of NaCl, we can use the molar mass to convert to moles. So for every 1 mole of NaCl, we have 58.44 grams of NaCl. Then for every 1 mole of NaCl, we have 1 mole of Cl minus. And then if we check our units, milligrams will cancel, grams will cancel, moles of NaCl will cancel, and we'll be left with moles of Cl minus over liters of solution, or the molarity of Cl minus. Doing the math, we get 2.4 times 10 to the negative 4th molar Cl minus. So now that we have our concentration of Pb2 plus and our concentration of Cl minus, we can calculate our QSP. This gives us 6.89 times 10 to the negative 9th. And our QSP is therefore smaller than our KSP, so we do not form a precipitate.